discuss about Euler Trapezoidal Predictor Corrector method. So if I take y a function of x, here this will be x axis and this will be y axis. So if I take a curve, this is curve, and if I join or take simply that point, so this will be point A and this will be on x point B. So here this will become a trapezium, and here this is A and this is B. Similarly this is A and this is B. If I take, similarly this point shows the height which is equal to h. So simply we know that if I form, this is a form of trapezium here. So if I take, this is y0 or A and by this B, so and I take this as height, so we know that area of trapezium is equal to 1 by 2 sum of parallel sides. These are parallel sides A and B, so this will be equal to, here this is in this diagram, this is side A and this is side B. If I take, so formula for this trapezium will be equal to A plus B multiply with h. So similarly if I take this point as y0 and this point as y1 and I take this is as height, so this will become y0 and this will become y1, this is height. So this will become area is equal to 1 over 2 y0 plus y1 multiply with h. So to form Euler trapezoidal predictor corrector method, so we will take area of trapezium. So simply we know that after this diagram, area of trapezium is equal to 1 over 2 sum of, say, parallel sides multiply distance between parallel sides. So here in this diagram, if we look or simply form this diagram, so this will be equal to 1 over 2 and sum of parallel side as we had discussed earlier, so this will be y0 plus y1 multiply distance between the parallel sides is h, so this formula will become 1 over 2 y0 plus y1 multiply with h. So this is area. So area of trapezium is 1 over 2 y0 plus y1 h. Similarly, if we write, as we know that y is equal to function of x, y, so similarly we can write area as 1 over 2, this will be f of 0 plus f of 1. As we know that y of dash is equal to dy over dx, which is equal to f of x and y. So if from xn to xn plus 1, if we take from xn to xn plus 1, so taking integration we can write area as xn plus 1 xn to xn plus 1 y dash of dx, which is equal to area, so this is equal to 1 over 2 f of, here xn and xn plus 1, so f of xn plus f of xn plus 1. So after simplification this will become y of, and putting the upper and lower limit, so xn plus 1 minus y of xn, this will be equal to this expression will be multiplied with height. So here also multiply with the height. So this will become height multiply 1 will be height over 2. This will become f of xn plus f of xn plus 1. So simply to form formula, this will become y of xn plus 1 will be equal to y of xn, or we simply can write it as, this can be written as y of xn plus 1 will be equal to y of xn h over 2. This will become f of n plus f of n plus 1. So this will become y of x. If I write here, this will become y of n plus 1 will be equal to y of n plus height over 2 yn dash plus yn plus 1 height over, this will become height over 2 yn plus yn plus 1, because fn will be equal to y dash. Similarly fn plus 1 will be equal to y of n plus 1. So this is called Euler formula. So if we write it as y of n plus 1 is equal to y of n plus h over 2 y of n dash plus y of n plus 1 p. So this formula is called Euler predictor, Euler trapezoidal predictor corrector. So this is predictor formula, and similarly if I write corrector, so this will be equal to y of n plus 1 m plus 1 c yn plus h over 2 yn dash plus yn plus 1 p. So this is called similarly simply this c shows correction or corrector. So this is called predictor. So we know simply here if we want to differentiate, so yn plus 1 is equal to yn plus h f of x n yn. This is our previous lecture, which was Euler formula or Euler method. This is Euler method. This is Euler trapezoidal formula. This is Euler trapezoidal corrector predictor formula. Here is p predictor formula, and similarly same is here, which is Euler corrector formula. So Euler simply, and this is Euler predictor formula, sorry, this is Euler trapezoidal formula. Here is the proof of this formula, and this is same formula, but this is predictor, and this is same formula, but this is corrector. So if we apply all these formulas 2, 3 and 4 and 1, so this is called Euler trapezoidal predictor corrector method. So here next we will discuss about example related to this topic. So here is example related to the our previous proof of Euler trapezoidal predictor corrector method. So simply we here step size is 0.1. So simply if I form a table, this will be x, this will be y. So this will be x0, this will be if I write it as this is x, this is y, x0, similarly y0, this will be 0.1, 0.2. So x 0 will be equal to 0, and because this is x0, and this is 0 0.1, x1 x2 will be equal to 0 0.2. So we want to find when x is equal to 0 0.2, so our last point x2 will be equal to 0 0.2. So this will be y1 and this will be y2. So if we solve this question, simply we know that the formula related to the Euler trapezoidal, first of all we will apply Euler method. So this will become by, if I write by Euler predictor formula, predictor, so you can write simply Euler formula, Euler predictor formula or method. So which is equal to y of n plus 1 is equal to yn plus h f of xn yn. Simply this is Euler formula. If I write here p, this will become Euler predictor method. So why here is p, so we will apply this into corrector formula. So Euler predictor method is yn plus 1 yn plus h f of xn yn. So simply if I write n is equal to 0, so for n is equal to 0, this formula will become y of 1, here will be b, y of 0 plus h f of x0 y0. So this is y dash, or you can write this as f of x n yn. This is equal to y dash, which will be equal to minus yn square over 1 plus x n. So simply this will become y of 0 is equal to 1 plus h is equal to 0 0.1. So f of x0 y0 will be equal to minus y of 0 square plus 1 plus x of 0. So this will become 1 plus 0 0.1. So this will become minus 1 square 1 plus x0 is equal to 0. So this will become 0 0.90. This is y1 of p. y1 of p is equal to 0 0.90. So if we want to apply two correction, similarly corrector formula is Euler trapezoidal corrector formula is equal to y of n plus 1. Simply this is the formula we had proved in previous part of this lecture. So this will become m plus 1 is equal to y of n plus h over 2, and this will become y of n dash plus y of n plus 1 p dash. P means we will apply this value here. So this will be equal to, if I take m is equal to 0 and n is equal to 0, n is equal to 0 shows first correction and n is equal to 1 will show second correction. So here we want to apply two corrections. So this will become y of 1 c0 will be equal to y of 0 plus 0 0.1 over 2, y dash of 1 will be equal to y of 0 plus y of 1 p. Y of 1 p is equal to here 0 0.9. So we will apply this into this expression. So this will become, if I write y of 0 is equal to 1 plus 0 0.1 over 2, y dash of 0 will be equal to minus 1 plus 1 plus 0 plus y1 of p will be equal to c minus 0 0.90 square. Here simply in this function we will take point as 0 0.90. So this will become 1 plus x0. here this will be x0, x0 will be, this point will be equal to minus y0 of p square 1 plus x0. So this will become minus 0, and this is x y1, so this will become y of 1 p and x of 1. So this will become minus 0.9 square 1 plus 0.1. So here we will put values 0.1. So this will become after simplification 0.9132. So value of y1c is equal to 0.913. This is first correction. So if our question is first correction, so we will put this question, answer here. And if uh, in question we are asked two corrections, so we will put y2 of c here final value. So m is equal to 0 and n will be equal to 1. N will be equal to 1, so second correction, this will be equal to y2 of c. 0 is equal to y. uh, Here in this formula n is equal to 1, so this will become 1 plus h over 2 y of 1 dash plus y of 2 dash p. So y of n is equal to 1, so this will become y1 of p dash. So this will be equal to, here this will be m is equal to 1 and n will be equal to 0, because this is uh, correction, second correction. So this will be y of 1 y of 1 c here will be equal to 2, because previous was first correction and this is second correction. So this will become y1 of c2 will be equal to y0 plus h over 2 y0 dash plus y1 c1. So simply y0 is equal to 1 plus 0.1 over 2. This will become y0 of dash minus 1 square plus 1 plus 0, plus this will become minus 0.9132 square plus 1 plus 0.1. So this will become 0.9121. This is y2, sorry, y1c2. This is second correction. So after second correction, this will be equal to 0.9121. So similarly, uh, here in this step for y1 we had applied two correction because we were given two correction. So final answer is this. If that is given one correction, so final answer will be this. Final answer will be this. Similarly, to find y2 we will repeat this whole procedure to find the value of y2. No, simply we will put here n is equal to 0 and for n is equal to 1 in Euler formula. So this will become y of 2 p will be equal to y of 1 plus h f of x1 and y1. So this will become y of 1. Here we will put y of 1 c. So this will be equal to 0.9121 because this is our final value, plus h is equal to 0.1 and this will become minus y1 square over 1 plus x1. So this will become 0.9121 plus 0.1 minus 0.9121 over 1 plus 0.1. So this is also c value. So this will become 0.8365. This is y2 of p. So after this, to apply correction, here n is equal to 1 m will be equal to 0. Similarly, n is equal to 1, m will be equal to 1. So for first correction and for second correction, so this will become, in this formula we will put the value, so this will become y of 2c1 will be equal to y of 1 plus, this will be 1 y of 1 uh, c plus h over 2, this will be y of 1 dash c plus y of 2 p dash. So this will become y1 is equal to 0.9121 plus h is equal to 0.1 over 2. This will become minus y1 square over 1 plus x1 and minus y2 of p square over 1 plus x2. So after value putting, this will become 9121 plus 0.1 over 2. This will be equal to minus 0.9121 square 1 plus 0.1 minus 0.8365 5 square 1 plus 0.2. So this will become 0.8451. Similarly, for second correction, n is equal to n was 1 and m will be equal to 1. So this will become 1, 2, c2 will be equal to y1 plus h over 2. This will become uh, y of 1 was c plus y of 2 c dash. This will become 0.9121 plus 0.1 over 2. This will become minus y1 square 1 plus x1 minus y2 c square over 1 plus x2. So this will become 0.8445. So this is our final answer, 0.8445 for the Euler trapezoidal method for two corrections. This was our question and was our Euler trapezoidal predictor corrector method.